Hello everyone. I'm Aman Pandey, a third year engineering physics student of IIT Roorkee. Today I'm going to explain you a different kind of transducer which is used in fish finding systems. I found this topic interesting because it was actually interesting to see how a non-technological field like fish finding requires so much knowledge of the technological term like transducer and related operations and efficiencies. So yeah, let's start. So the first question is why would we need a transducer? So the basic operation of a fish finder system involves changing the electrical signals to acoustic energy, which can travel through the water, and they get reflected or bounce back from some opaque surface, and then get back, and the echo is received by the transducer again, and then converted into electrical signals back, and thus we require the transducer. The echo sounder is also a part of the fish finding system, which interprets this incoming signals and also works on transmitting the pulses through the transducers. Uh, so the echo sounder and the transducer uh, make both of them combined make the total fish finding system. The transducer listens for 99% of its working time and only transmits one, between 1% of its time. But because of the we are talking about short durations like a scale of 1 microsecond, so it is still a very short duration in which the transducer will transmit an electrical pulse. Yeah, so this slide right here explains how the depth transducer is structured. We can clearly see that it consists of a cable, a housing, a sound absorbing material, a acoustic window, and a piezo ceramic material. The piezo ceramic element is the main part of this transducer, which performs the action of converting the electrical signals into sound energy and vice versa. Uh, Also, depending on the time of the return of the echo, echo sounder calculates the distance of the target particle, target surface, and thus throughout the boat's travel, it can locate unevenness or curves along the surface, and also uh, different type of things underneath, such as fishes, and that's why we use fish transducers in fish finding systems. In this picture, we can clearly see a side scan sonar which emits the audio waves sideways so that a 3D image can be generated. 3D image of the bottom can be generated, and if there is a difference in height, like if there is a ship in between, it can like the echo sounder shows a shadow of that ship, and thus we can detect different objects and sense different objects on the bottom of the surface. Okay, so we talked about detecting fishes using transducers. So how would this happen? Basically, fishes contain air bladders filled with gases around their gills, and these gases result in a low pressure area around their gills compared to other part of the fish body, which consists of mostly bones and fleshes. So, because of this low pressure area, the sound is reflected in a different way in this region compared to the other region, and whenever the boat moves down a fish, or the transducer receives such a difference in signals, it it can the echo sounder can interpret this difference as a fish, and it can then transmit this information to a user in a friendly way. So also the frequency of the signal transmitted also matters for this efficient operation. Low frequency uh, Low frequency signals travel more depth, and thus they can be used to like explore canyons and other things. But if we need a like a high resolution picture, and if we are like working in shallow waters and such things, we can like work out with uh, uh, with the high frequency signals, uh, so that we get a more clear picture of what's happening beyond. Also, about the fishes, they can't hear the sounds because they are mostly beyond their hearing range. So that won't be an issue, like disturbing them using the sonar or such frequencies. So now we have explained like the transducers working and why we need it. We will be like covering how can we make this process efficient, and this is basically done by this is basically done using different type of transducers and based on which application we need. Like every transducer has its own pros and cons, and we would need a different one based on what purpose we are serving. So basically they are classified according to the mounting styles, which means like where the transducer is mounted in reference to the boat. There are three basic classifications. The first one is transform mount, which is like mounting the transducer in a transform way to the boat's hull. And there is a second type, which is the through hull transducer, and the third type is the in hull transducer, which is inside the hull of the boat. And these are different type of ways to mount a transducer. So So for all these types of mounting, there are some ways we can make these mountings more efficient. Like it is some kind of calibration for the measurement and analysis of the signals. So for example, for transform mounting, we can like mount a sensor as close to the center line of the boat as possible. For the through hole mounting, we would require the transducer to be under the water at all times. And for the in-hull mounting, we would require the transducer where the hull connected with the transducer uh, to be in contact with water all of at all times. So these are like different ways to make the transducer mounting efficient, but there are some general tips. One of which is that the transducer should be mounted in such a way that the water flow around it is smooth, and like the turbulence and bubbles are minimums. Especially this need to be considered, especially when we are like working at higher speeds. So it's clearly evident that every mounting style has its own pros and cons, and we need to use a suitable transducer based on our purpose. And also, once we have selected, we need to calibrate it to maximize its efficiency. There is an article over the selection guide of the transducer, which I have mentioned in this link. One can read it to analyze different type of mounting and their pros and cons. So after characterizing the efficiencies and all of the related stuff, we would also need to characterize the uh, power uh, power required for a transducer for different purposes. So the size of the transducer determines the power of it. Like in general, the bigger the size, the more power the transducer has. And for any purpose, the power of the transducer should match the power of the echo sounder for the optimum performance. Like if the power of the echo sounder required is low, then transducer should not be high unnecessarily. So clearly see that for small recreational fishings, just for entertainment purpose, we can easily use a less powered transform mount or a through hull mount transducer. But for deeper explorations, or mapping the sea surface, or maybe more professional level fishing, one can use a powerful 1 kilowatt or 2 kilowatt transducer with a through hull or in hull design. On the left picture, we can clearly see the difference between power levels. The B744V is a 600 watt powered transducer, while the B260 or the SS260 is a 1 kilowatt power transducer. So we can see that for different frequencies, the V260 goes to a higher depth penetration, and thus is efficient in many purposes, like tournament sport fishing, or mapping the ocean surface, etc. uh, it is also very precise, and it has a high sensitivity, uh, so it is ideal for professional fishing and etc. purposes. Also, one of the terms associated with a fish finding system is the quality factor of the transducer. So the quality factor is the amount of ringing the ceramic element undergoes when some power is applied to the transducer. So if if a high power is applied to the transducer, the lower if the transducer undergoes lower number of ringing, then it is a high quality transducer and its performance is generally considered better. So yeah, that was all for this presentation. I hope it was an interesting topic to explain, and it explained how we can apply the transducer technologies to like in commercial purposes, and how analysis about the technological terms like its quality, its efficiency, and its working is required, even if one is not from an engineering background, but he or she requires this specific device to like uh, to for whatever purpose. Maybe it may be recreational, or it may be like professional one. uh, I hope you will be able to catch a fish after this presentation. Thank you.